So our goal today is to learn different techniques of differentiation and talk about applications of those. So particularly we want to talk about derivatives of power, sums, and constant multiples. So in order to work through the problems today, you will need to make sure you understand the following rules. If n is any constant, okay, so if n is any constant and f of x equals x to the n, then f prime of x is equal to n x to the n minus 1. If f and g are any two differentiable functions, and if c is any constant, then the sum f plus g, the difference f minus g, and the constant multiple c times f are all differentiable. Okay? That is, if you start out with f and g are differentiable, then the derivative of that sum f plus g will be equal to f prime of x plus g prime of x. And I'll zoom out a little bit or zoom in. The difference, the derivative of the difference is equal to f prime of x minus g prime of x. C is a constant, so the derivative of c, f, the derivative of that is equal to c times f prime of x. So in other words, constants play nice with derivatives. Okay, so that's the constant multiple rule. Cx prime, what's the derivative of x? See, blank looks, it's 1. So this would just be equal to c. The derivative of x is 1. X prime is equal to 1. So cx prime will be equal to c. Okay? C prime, if you take a derivative of a constant, you will just get 0. Okay? So these are the rules. Okay? So these are the rules for derivatives of powers, sums, differences, and constant multiples. Okay? So now what we want to do is apply those techniques, apply those rules. Okay? You're using this rule here. So you have x to the 4th. So your derivative will then be 4x to the 4 minus 1. So using this rule here. So we want to calculate the derivative of the following. And you might want to remember what your rule was for the first rule that we talked about. So whenever you have a power. So here we have f of x is equal to x to the 4th. The rule on the previous page tells us that f prime of x will be what? I can't hear you.
1 to the 4th.
No. Let's go back. So we would have this is equal to 4x to the 4 minus 1. In other words, we get 4x cubed. So that will be the derivative of x to the 4th. And what these rules do for us, it gives us a shortcut for finding the derivative instead of having to use the definition that you learned last class all the time. Okay? So for f of x equals 3x to the negative 1, tell me the steps we take to finding its derivative. Yes?
You would multiply the negative 1 by 3.
Good, so you have negative 1 times 3.
And then x, when you do negative 1 minus 1.
Very good. Very good. So we get negative 1 times 3 is negative 3, and x to the negative 2, as you said. Very good. So that's your answer here. The only other thing you could do here is rewrite this without negative exponents, which I'm not asking for right now, but knowing how to do so will help you in the future. The only other thing you could do here is rewrite it as negative 3 over x squared. Remember, you could remember the rule that allows you to do that? I see heads nodding yes. Okay. All right, so that's the only other possibility. Now, for g of x is equal to 1 over x plus 1 over x squared. What should we do in order for us to find the derivative? So as he said online, we need to change 1 over x to x to the negative 1. So we write this is x to the negative 1. And how do you rewrite 1 over x squared? As x to the negative 2. Good. So we have x to the negative 1 plus x to the negative 2. Would you like a minute to find the derivative? Okay. What do you have for the derivative here? Go ahead, Haley.
Negative 1 over x squared minus 2 over x cubed.
You said negative 1 over x squared minus 2 over x cubed.
Yeah.
Does everyone agree? It's a question.
Wouldn't it be
Raise your
plus?
hand if you agree. Go ahead.
Wouldn't it be plus?
I heard, wouldn't it be plus?
Yeah.
So I heard, would we have negative 1 over x squared plus 2 over x cubed? Yes?
Why does it have to be like, I just got 1 over x squared plus 1 over x cubed.
You got 1 over x squared plus 1 over x cubed?
Yeah, because I got like x to the negative second plus x to the negative third.
Okay,
And I just turned it back into.
okay. Did anyone get anything else? Okay, let's take a minute and let's write it out using the rules from the previous page. Remember, whenever you have x to the n prime, that's equal to nx to the n minus 1. So that's the rule. Okay? So the derivative of x to the negative 1 is equal to negative 1 x to the negative 1 minus 1 plus negative 2, because remember we have to bring this down. So negative 2 times x to the negative 2 minus 1. Draw a line here to separate our possible answers. Okay, so simplifying here, this becomes negative 1 x to the what power? Negative 2. Good. And then plus a negative makes this what? Minus. Good. Minus 2 x to the what power? Negative 3. So we should have negative and we should have minus. X to the negative 2 is the same thing as 1 over x squared, but you have a negative out here, so this is negative 1 over x squared. And then we have minus 2 over what? X cubed. So which is our correct choice? Red, blue, or green? Red. You got it. So this is the answer here. So that's not it, and that's not it. Does that make sense? What questions do you have? Yes, question?
If you go up to the x to the negative first plus x to the negative 2.
X to the negative first here.
Yeah, would we not be able to combine into one term?
They're not like terms. They're not like terms. Remember, they have to be like terms. So if it were x to the negative 2 plus x to the negative 2, then that would be 2x to the negative 2. But they have to be like terms in order for you to add them. You're welcome. What other questions do you have? Okay. Number 4 says y is equal to 4 over 3x squared plus 1 over x to the 3.2. Find the derivative of y with respect to x. This is Leibniz notation, which is saying the same thing as finding y prime. Find y prime. Would you like a minute? That's a question. Would you like a minute to try it? Okay, go for it. Find y prime. All right, how should we rewrite this before we differentiate? You want it? Go for it. How do we rewrite y? Not everybody at once. Yes.
4/3 versus x to the negative 2,
Good.
plus x to the negative 3.
Very good. Very good. So you have 4/3 x to the negative second plus x to the negative 3.2. You got it. So now when we differentiate, what do we do? Yes. Sorry, I didn't see your hand. It's like right here with this corner where there's nothing here I can see. Go ahead.
You multiply the negative 2 by the 4 divided by 3.
So let's write that step. So if you said 4/3 times negative 2.
Yeah.
Okay, go ahead.
We get negative 8 over.
Let's wait until, let's do that in the next step. Finish this part.
And then, that would be x to the, negative 3.
Good, because you'll have negative 2 minus 1.
Yeah.
Let's write that step in initially, and then let's go in and simplify after.
Okay.
Okay, so then what's the rest?
Then you would multiply the negative 3.2
So what goes in between?
plus.
Plus, good, and then you said negative 3.2, good.
And then negative 3.2 minus 1.
You just write negative 3.2 minus.
To the power.
Oh, what goes there though? You said to the power? Good, x to the negative 3.2 minus 1. Very good. Now go ahead and simplify like you wanted to.
It would be negative 8/3
Mm-hmm.
x to the negative 3.
Good.
Minus 3.2 x to the negative 4.2.
Very good. Very good. And if you want to write this back into the original format, what would that be? Go ahead.
Negative 8 x to the third over 3.
No, not negative 8x to the third over 3, because this is on the outside technically. So that's x to the negative third times this. You wanted to jump and help?
Negative 8 over 3x to the third.
Negative 8 over 3x to the third. Good. Who wants to finish it?
Minus 3.2 over x to the 4.2.
You got it. Very good. That's it. That's your derivative of y. What questions do you have? What questions do you have? Practice mates, perfect. Let's do another example. Let's do another example. Let's do another example. So here, y is equal to 4x squared over 3 plus x to the 3.2 over 6 minus 2 over 3x squared plus 4. Find the derivative of y with respect to x. So again, this is just a check-in to make sure that you're on the right track. How did you rewrite y whenever you're finding, before you find the derivative? Yes, Haley?
4/3
4/3
times x squared.
times x squared. What else?
Plus,
Uh-huh.
1/6 times x to the 3.2.
Good.
Minus 2/3 times x
Minus 2/3 times
squared.
what?
X squared.
No, not
Oh,
times x squared.
X to the negative 2.
X to the negative 2 because you brought that outside. So that, and because it was in the denominator, it now becomes a negative. Good. And then
Just 4 just stays.
4 stays there, right? Because it's just a constant. So in order for us not to change the equation, we just leave that there. Okay? And then you find the derivative of this. Now it looks like we can apply those rules from page 1 to this. All right, let's find the derivative. What do we get? Like the same 3 or 4 people answer, the same 4 people answer. No, I should say 5, including online. What should we do here? Yes,
Well, you do 2 times 4/3
so you have 4/3.
times 2.
Why did I do that? 4/3 times 2,
And then x to the 2 minus 1
2 minus 1, good.
plus
Mm-hmm.
3.16 times 3.2
Times 3.2, mm-hmm.
to the, or x to the 3.2 minus 1.
Good.
And then minus 2/3 times -2. And then x to the -2 minus 1.
-2 minus 1.
Plus 4.
Plus 4, you said?
Yeah.
Oh, careful.
Oh.
4 is a constant.
So this is
Plus 0, you got it, plus 0. Because 4 is a constant, the derivative of a constant is 0, so we add 0. Very good. Now when you simplify this, you get what? Four thirds times 2?
8/3.
8/3, good. So you get 8/3 x plus,
8/15 x 2.2.
say it again?
8/15 x to the 2.2.
You said 8/15?
You, no.
What?
I did 3.2.
3.2 over 6, right? So you get 3.2 over 6, x to the what? 2.2 plus 4/3 x to the what? No, what's -2 minus -3? Good. Now we can rewrite this similar to the format it was given, right? So rewriting it in a similar format, we get 8x. Good. Continue.
Plus 3.2 x to the 2.2 over 6,
Good.
and then minus, plus 4 over 3x, to the third.
Good. Good. And that's your final answer. What questions do you have? Yes?
Will we need to simplify 3.2 over 6?
No.
Okay.
That's what he was doing. So it's the same thing. They were given the correct answer. Everybody just had puzzled looks. That's why I just gave it a minute. They were given the same thing. They just simplified it. Okay? 6, s of x equals x plus 7 over square root of x. Before we do this, were there any more questions about example 5? Okay, example 6, s of x equals x plus 7 over the square root of x. What should we do first here? You want it? Just go ahead and say what we should do. Go ahead.
Well,
Simplify the square root of x.
So how would we write s of x then? Well, you're rewriting the entire thing, so what goes first? Go ahead. To the -1/2. Good. Would you like a minute to find the derivative?
sure.
Find the derivative and put it in, after you found it, put it in the same format, in a similar format as s of x. So what's s prime of x? What is s prime of x? Yes, go ahead.
1 plus 7
Times -1/2
x, and then
-1/2.
raised to -1/2 is 1.
Very good. Now, simplify it. What do we get? Did you leave it as this?
No.
No? Go ahead.
1 minus 7 over, and this is where I forget how to
I-
write the square.
I
where
can
the
help
3
you.
goes and-
So first, rewrite this as 1 minus 7 halves x to the what power?
Negative 3.
-3 halves. Good. So then, go ahead and start telling me, and I'll help guide you through it. You said 1 minus 7 over.
Well, it's gonna be 2,
Mm-hmm.
and then it's gonna be the root of,
That's right. So whenever you write,
will that be cubed, right? Or,
say it again.
is there gonna be a 3 like in the index?
No, that the denominator gives you your index. So the 2 is an understood right here,
Yeah,
and then you would write
x
x cubed there. Very good. You write x cubed there. And then because you have x cubed underneath the square root, you could rewrite that as x squared times x here. But the square root of x squared is what? What's the square root of x squared? X, right? So you could rewrite this as 1 minus. I would accept this. Let me start by saying that. I will accept that, but you also need to make sure you're able to identify the answer as being 1 minus 7 over, that's a large 7 for some reason, 2x, the square root of x. So you can write that, or you can write that. What questions do you have? Okay, example 7. Was there a question online? Okay, so example 7, we have a is equal to 4 pi r squared. Here we need to find the derivative of a with respect to r. How do we do that? How do we do that? Multiply, so you have 4 pi times, what's the derivative of r squared? What's the derivative of r squared?
2r.
2r, good. So you have 4 pi times 2r, which gives you what? You got it. Good. 8 pi r. That's your final answer. What questions do you have? Okay, good. So now remember the derivative is really just saying, okay, we find the slope, right? So now we can go back to the things that we've talked about before, like find an equation of a tangent line for a graph at a specific point. But now we're going to incorporate the derivative here. So example 8, we're going to find the equation of the tangent line to the graph of f of x equals 1 over x squared at the point with x coordinate x equals 1. So we need to find the equation of the tangent line to the graph of f of x equals 1 over x squared. Okay, remember that your equation typically is given by y minus y1 equals m times the quantity x minus x1, right? M, how do we find m? We find the derivative, right? That's your slope. So it's going to suffice for us to rewrite f of x as what? How do you want to rewrite it?
Well, we can write x to the negative second.
Good. Rewrite it as x to the negative second. Very good. Right? And then we know what x is. X is equal to 1. So we know what x1 is. We should find out what y1 is. How do we find out what y1 is? You plug 1 into into the equation here. We don't have to use this. That was just rewritten for us to find the derivative. So we find f of 1 to find the corresponding y. So f of 1 is equal to 1 over 1 squared, which is just 1. So that's our y1. So that's equal to our y. Okay? Our y1. All right, x1. Okay? So f prime of x is equal to what? Now you can just tell me what we get.
Negative 2 over x cubed.
-2 over x cubed. Good. And now you, in order to find m, what should you do?
Plug in 1.
Plug in 1 into the derivative. Good. So the notation, remember, was f prime of x evaluated at x equals 1. That was the notation. So that's equal to -2 over 1 cubed, which gives us what? -2. Good. So our equation would be given by, so that's our equation, is y minus 1 equals -2 times the quantity x minus 1. Or if you put that in slope-intercept form, you would have y is equal to -2x plus 2 plus 1, or in other words, what?
Y equals -2x plus 3.
-2x plus 3. So your equation would be y equals this. What questions do you have? No questions? All right, let's keep it moving. So for example 9, it says, see the graph of U.S. Math SAT scores as a function of parents' income level on page 835, which is number 100 in your textbooks. This is the graph here. Can you read that? Okay. The regression curve is given by f of x equals -0.0034x squared plus 1.2x plus 144. This is it. Where x is greater than or equal to 10, but less than or equal to 180. Okay, so x starts at 10 here, 180 here. Okay, where f of x is the average math SAT score of a student whose parents earn X $1,000 per year. Find f prime of x and compute f prime of 100. So find f prime of x and compute f prime of 100. What does the answer say about math SAT scores? Okay. So here, to find, first we have to find f prime of x. So this would be equal to f prime of x is equal to -0.0034 times 2x plus, what's the derivative of 1.2x? 1.2, good. So this would be equal to -0.0068x plus 1.2. So we just found f prime of x. Now it says compute f prime of 100. So f prime of 100, take a minute and tell me what that is going to be. So -0.0068 times 100 gives you what? Negative 0.68, good, plus 1.2 gives you what?
0.52.
0.52, good. So, just to put this in perspective, because this says, what does the answer say about math SAT scores? That means, notice that where f of x is the average math SAT score of a student whose parents earn X thousand dollars per year. So what this means is we have 0.52 points per $1,000 increase in income, okay? So this means we have 0.52 points per $1,000 increase in income. So what this means is at an income level of, I can write it out, it means at an income level of $100,000, a student's math SAT score increases at a rate of 0.52 points per $1,000 of additional income. So students do better whenever their parents have more money. Okay? What questions do you have? So now, building off of this, we'll do part B of this question. We'll do part B of this question. So, does f prime of x increase or decrease with increasing x? What does your answer say about math SAT scores? So let's write out f prime of x to remind ourselves. So f prime of x was equal to negative 0.0068 x plus 1.2. This is a line with what kind of slope? Positive, negative, what? Negative, right? So, is it going to be increasing or decreasing? Decreasing, very good. So, this derivative is linear with negative slope, and thus it is decreasing when or with increasing x. And it said so we answered the first question. Now the second says, what does your answer say about math SAT scores? This says that a student's math SAT increases at a slower and slower rate as her parents' income increases. Okay? So, a student's math SAT increases at a slower and slower rate as her parents, his or her parents, or their parents, income increases. Okay? What questions do you have? Okay? You have some functions that are not differentiable. You have some functions that are not differentiable at a specific point. So you have some functions that are not differentiable at a specific point. Consider y equals the absolute value of x. That's this function. This is not differentiable at 0, okay? So remember, the absolute value function is defined as x if x is greater than or equal to 0, and it's defined as negative x if x is less than 0. So y prime would be equal to the derivative of x is what? What's the derivative of x? 1. Good. So you would have 1 if x is greater than or equal to 0, but what? If x is less than 0. I can move this up. There you go. I'm glad you moved over so I could see that you could not see the bottom. So here, again, you have y prime is equal to 1 if x is greater than or equal to 0, but then it's equal to what if x is less than 0? Negative 1. Good. So we say that the function is not differentiable at 0. So not differentiable at 0. Another function we can consider is y equals x to the 1/3. Y prime would be equal to 1/3 x to the 1/3 minus 1. That would be 1/3 x to the negative 2/3, because you can rewrite 1 as 3/3. So then that gives you 1/3, the cubed root of x squared, which means this is undefined at what? Good, it's undefined at 0, so it's not differentiable at 0. Bless you. You're welcome. So it's undefined at 0, it's not differentiable at 0. Okay? What questions do you have? Would you like a break? I see no, so let's keep moving. So that concludes section 11.1.